The universe is a vast, unexplored vacuum of emptiness and promise, and humanity as a whole has explored almost none of it. Even so, we have found incredible things that don't align with our worldview and challenge the very basis of scientific understanding. You wouldn't believe some of the crazy stuff that's been discovered out there.
And we're going to let go. Ready, set, let go. It's floating on a sea of sulfur hexafluoride.
We thought scientists knew what they were talking about, but some of the physics-defying stunts on this list really put that to the test. Here are 15 of the craziest things that seem to defy the very laws of physics. Number 15. The sun can make things hotter than itself. The Earth's resident star is an incredibly beautiful but extremely complex thing that has baffled scientists for as long as physics has been a thing. Most of its behavior has been explained away at this point, but there is still one little thing that's difficult to understand and has left scientists scratching their heads. Dubbed the corona effect, the sun is able to heat things so that they are hotter than the sun itself. This may seem counterintuitive, and that's because it is. The reasoning for why this happens is very poorly understood, though many believe that it has something to do with the ratio between particle mass and particle speed. The corona is effectively the outer layer of the sun. It is a mass of plasma and heat that is somehow able to cause mass to heat up to a point where it's hotter than the sun. Until we can figure out how or why it does this, it'll remain a mystery in the minds of many. Number 14. Military Invisibility Cloak. If you've watched Harry Potter, chances are that you know about the Invisibility Cloak. It's one of the most important items in the franchise and helps with a lot of the major plot points throughout all of the books and movies. Well, it turns out that an invisibility cloak has been developed in real life and is currently in the process of being bought out by the military. The company Hyper Stealth Biotechnology has created a sort of image warping material that is able to bend light around the wearer, effectively making it seem like they aren't there. This, of course, would be useful in any number of situations, specifically replacing the typical green camouflage with a specially made invisibility cloak would allow for much easier stealth missions, and could help with escorting hostages away unseen. It's incredible to see being developed that were once relegated to the world of fantasy, but that seems to be the direction that a lot of modern technology is going. Very soon, we could have all sorts of incredible gadgets that we never thought we'd see in real life. Number 13. Temperatures below absolute zero. Depending on where you're watching this video from, chances are you use either the Celsius temperature scale or the Fahrenheit temperature scale. We're not going to argue over which one is better, as that's been done 100 times before, but we are going to discuss a concept that doesn't really exist in either scale: absolute zero. Absolute zero exists on the Kelvin scale, and it is the coldest possible temperature for mass to exist at. Heat is created by the movement of particles at the atomic level, and absolute zero is the temperature at which those particles are completely still. And yet somehow scientists have created mass that is colder than absolute zero. It involves some very complex math, as well as something called the Boltzmann distribution, which is far too complex of a scientific principle for this video. What you realistically need to understand is that the gas they created has some weird properties that acts almost like we expect antimatter to act. It also requires a lot of energy to keep that gas at temperatures that low, considering it's at numbers that can't even be conventionally understood. The scientists go through a lot of effort to keep things as cold as possible. It has little application, but it's always cool to see boundaries broken in science. Number 12. Higgs mass hierarchy problem. If you're knowledgeable in the field of physics, you'll understand how important the Higgs boson particle is. Before its discovery, we had a very little understanding in regards to how gravity worked, how mass was distributed, and overall how the universe stayed together. The Biggs boson particle, for those that don't know, is the thing that gives everything in the universe mass. Mass by extension is what causes things to be impacted by gravity, which is one of the most important fields in the universe. The force due to gravity is generally well understood, but when looking at the microscopic level, things stop making sense. In fact, if you look at small enough masses, gravity effectively disappears entirely. This, of course, is a problem. Forces in the universe are supposed to be scalable. They should impact things at small sizes just as they do with large sizes, and yet this is not observed with gravity. This is known as the Higgs mass hierarchy problem. This important little particle has made it so that gravity as we know it is in a limbo of understanding. Number 11. Particle that is matter and antimatter. The concept of matter is one of the most mysterious things in the universe because for the life of us, we cannot figure out why everything is made of matter. Realistically, when the universe formed, it should have been equal parts matter and antimatter. This would have led to the direct annihilation of the universe right away, of course, because the two would destroy each other. And yet here we sit on our chairs made of matter, watching videos on screens made of stuff, and overall living an annihilation-free life. One of the secrets to understanding this could be found in the Majorana fermion, which is a particle that could effectively act both as matter and antimatter. This means that the particle is capable of self-annihilating, and if this happened enough that the universe was left as mostly matter, it could work. The rough part is that proving this requires seeing what is likely the rarest interaction in the universe. It is estimated to happen once every 100 trillion years across the entire universe. Luckily enough, we've created something remotely similar in a lab. These Majorana fermions may actually be incredibly important in quantum computing because they are very stable in relation to the other possible particles. Overall, the secrets of the universe may still be in question, but humanity will always march forward with technology. Number 10. Floating aluminum foil. Science creates some of the best magic tricks in the world. If someone doesn't understand how something works, they are very likely to just label it magic without trying to figure it out. This has often been the result of the floating boat trick, in which an aluminum boat is seemingly suspended in mid-air in a tank. This is, of course, not magic, it's science. The tank that the boat is floating within is not filled with normal air, but rather sulfur hexafluoride. This is a comparably dense air, much denser than the normal nitrogen-rich stuff we breathe every day. The result is that the aluminum boat is less dense than the gas and floats on top of it. Sulfur hexafluoride actually has another use, in that it can behave sort of like helium's arch nemesis. Helium is an incredibly light gas, and that's why it makes someone's voice high when they suck it in. Sulfur hexafluoride, on the other hand, does the opposite. It makes someone's voice incredibly deep, almost demonic. This is a cool demonstration and often leads to appreciative applause when performed for crowds. Number 9. Nitinol, the memory metal. The video you're watching now might seem like it's edited or played in reverse, but I can assure you that it has not been altered in any way. The mysterious, wonderful metal that you're watching is called nitinol, also known as nickel-titanium alloy. It was developed initially by the U.S. Navy and is now widely known due to a property known as thermal memory. This property allows for the metal to be formed at an initial temperature and then cooled down to room temperature without much hassle. It's a rather malleable metal, so it can be twisted and bent and changed in a myriad of different ways. The magic happens, however, when the heat is applied to the metal once again and it begins to change. The microscopic bends in the metal structure, known as stunts, allow it to keep a sort of memory of what shape it's supposed to be. So when heat is added, it reforms to what it was at the beginning, which seems like a sort of magic when viewed without any knowledge of the stuff. This is extremely useful in things like medical devices. If formed at body temperature, surgical implants can be made that open up after insertion, and that's only one example of how it can be used. Nitinol could be an incredibly powerful invention, and right now it's barely been used for anything other than paper clips. Number 8. Herons Fountain. Herons Fountain was an incredibly important invention for its time, considering it was created around the 1st century AD. Yeah, it's old. It was invented by physicist Heron of Alexandria, who studied air pressure and steam throughout most of his career. He even described the process to create the first steam engine, though he never got the materials or the brainpower together to create it. This fountain is used in physics classes today in order to demonstrate the principles of hydraulics and pneumatics, and it's quite simple to construct with simple materials. 3 containers and 3 pipes are all that's needed, so generally soda bottles and straws are used to keep things cheap. Although the fountain looks like a perpetual motion machine, such a thing is impossible, and this is not actually the case. The fountain may operate for several minutes, but it will eventually come to a stop once it's run out of energy. This fountain makes great use of gravity and pneumatic pressure, and it's a great introduction to several complicated physics topics. Number 7. Reverse waterfalls. Waterfalls are some of the most majestic places on Earth, and their massive splendor and beauty make them key destinations for many people. That's why the thought of a reverse waterfall is so strange. The idea of water going upwards, up the rock slope and towards a source rather than away from it seems impossible. Well, they exist. There are many fake videos of them, so you have to be careful when searching online. But there are plenty of true examples to find if you're careful enough. The ones you're watching now are real-life examples of reverse waterfalls, and the way they work is rather simple once you understand it. Waterfalls work because the force due to gravity brings water down towards the ground, eventually crashing into whatever's at the bottom. In the case of a reverse waterfall, the wind at the top is strong enough to be either equal to or greater than the force of gravity, which forces water up and back rather than forward and down. It's incredible that something with such a simple explanation can look so mystifying and seem so impossible in real life. Number 6. Lahaina Noon. Lahaina Noon is a phenomenon that occurs in several places throughout the world, but the most famous and most prominent example is within Hawaii. This is where the phrase was coined, and it's where most research on the phenomenon is conducted. Lahaina Noon occurs exactly at solar noon when the sun is directly overhead, bearing down on the Earth. In a few very specific places in the world, the sun is positioned in such a way that it's directly above man-made structures, meaning that it eliminates their shadows. Shadows are only cast due to light being blocked or reflected at different angles, so when the angle is perfectly straight, there is no blocking to be done. Before people knew what caused this, they were often freaked out whenever this occurred. Seeing a landscape without shadows is actually incredibly creepy, because the brain is accustomed to just tuning shadows out whenever they aren't necessary. Because of this, having them not be there forces the brain to realize it, and it makes most people uncomfortable. It's interesting that such a cool phenomenon only occurs in such specific places. Most people will never experience it in their lifetime, making it a pretty special occasion. Number 5. Krishnas Butterball. When people think of physics-defying, one of the most common examples would be defying gravity. It just seems so absolute, and anything that can directly defy it must be incredibly powerful for some reason or another. Krishnas Butterball is an example of this. It is a large boulder positioned very specifically on a large slope, and although it looks like it should fall at any moment, it hasn't in the many years it's been there. Nobody actually knows how the boulder got there and how long it's been in the same spot. But there are Hindu myths going back centuries that speak of something that resembles it. They tell that the god Krishna was fond of stealing butter, and the stone is a dollop that the god dropped. The slippery stone that the rock is positioned upon is actually used by many children as a slide, reinforcing how strange it is that the stone can rest there. People have tried to push it down to no avail. It's as though it's stuck there for all of eternity, never meant to move. The best part is that often the local goats like to climb up on top and look out across the horizon. It's actually pretty adorable. Number 4. Cairo floating stones. Much in the same vein as the previous entry, the stones present at the Cairo airport defy physics in that they appear to go against the very definition of gravity. One of the stones is sitting flat on the ground, while the other is floating in the air above it, attached with nothing but a rope to the bottom stone. Unlike Krishnas Butterball, we actually know how the floating rock works here. The two rocks are actually an art exhibit by sculptor Shaban Abbas, who was one of the most prominent sculptors in the Egyptian contemporary art scene until his unfortunate passing in 2010. The sculpture uses very strong magnets in tandem with a rope made of stone in order to keep a very particular balance for the top rock. The magnets, along with gravity, hold it in place despite it looking like it's off-center. Magnets actually have the capability of shifting an object's center of mass if used correctly, which is how the rock is able to remain suspended in the air. If you're ever flying into the Cairo airport and see the sculpture, you'll understand how it works and why it looks so interesting, while everyone else has to try to figure it out. Number 3. The Flyby Anomaly. Satellites are some of the most important inventions that humanity has ever come up with because they allow us to interact in a meaningful way with things that are far out of our normal scope of observation. From flying far out into the universe to remaining around the Earth as a telescope, satellites have many purposes, but all use gravity in order to maintain their speed and flight path. This is why the Flyby Anomaly is so incredibly frustrating. It seems to defy everything we currently know about physics. This anomaly occurs whenever satellites orbit Earth. It doesn't always occur, but sometimes there are very slight increases in a satellite's speed that are completely unexpected. You would think that a tiny speed gain doesn't make much of a difference, but you'd be completely incorrect. In space, it should be impossible to gain speed without using fuel. Newton's laws state that energy cannot be created or destroyed, and yet this increase in speed seems to come from an unexpected increase in kinetic energy. There have been no convincing explanations for why it occurs, and overall scientists are just completely stumped. Considering how big of a discrepancy this is, it's surprising it's not talked about more. Newton's laws are pretty much the foundation of physics as a whole, so something contradicting them in nature is a huge issue. Number 2. Black hole information loss. It's no surprise to see black holes on this list, considering how they seem to be just enormous balls of physics-defying mess. What we'll specifically be focusing on in this example is the information loss paradox, because that's the largest contradiction between them and our current understanding of physics. To understand the information loss paradox, you must first understand how information works in the universe. Effectively, every single action, reaction, movement, sniffle, breath, and everything else you can think of is made up of information, and that information is never lost. It may change forms, but information cannot be lost within the universe. It's part of a larger theory of parity, where a universe should be able to move forward and backward without contradiction. This all breaks down when it comes to black holes. Anything that goes into a black hole seems to have its information completely wiped out. Either that or it's completely inaccessible to humanity in some form. This is a huge issue because it breaks a lot of laws of physics. In order for anything to work, information must be preserved. That's why there are many different hypotheses on where black holes actually keep this information rather than wiping it out entirely. This is currently one of the holy grails of physics, so to speak. It's an incredibly important problem to figure out. Number 1. Quantum Xeno effect. You may have heard the saying, "A watched pot never boils." This is obviously false. It might feel like it's taking longer to boil because you're bored, but a watched pot will eventually boil if you watch it long enough. There's a physics equivalent, however, and that may not be the case. One of the most important aspects of physics is quantum decay. When a particle is unstable, it will decay at a rate that is generally predictable and can be measured. However, a team of scientists in Texas decided to observe uranium as it decayed and found that while they were watching it, it never decayed. These findings were replicated across the world, and it was eventually determined that yes, certain particles will never delay as long as they are observed. This means that you can effectively stop time from affecting certain particles as long as you're watching them. It seems impossible, but it has been verified hundreds of times by different independent scientists. This is, of course, incredibly strange and could have massive repercussions on things like quantum computing and nuclear energy. Only time will tell. So which of these 15 things do you think was the craziest? Do you think that physics will explain these anytime soon? Leave your answers down in the comments below and let us know if you've ever seen anything that breaks the laws of the universe. Like and subscribe if you're a fan of the content, because we're always looking to bring new and exciting information to the masses. Stick around for future videos by hitting that little bell icon, and we'll see you in the next one.